Alright, so now let's sort of formalize the steps that we just took in the last example. So what we did was really called Gauss-Jordan Elimination. And it is, very similar to the elimination we've done with equations before, but it's a very systematic way of solving systems of linear equations by using matrices. So here are the steps. 1. So we choose the leftmost non-zero column in the matrix, and we get a 1 in the upper left. So that means, if I have a matrix that looks something like this, I look for the first non-zero column, which is this. This is all zeros, this is non-zero, and I want to get 1 to the upper left. So here I could either swap the first two rows to get a 1 onto the top. So here I just swapped the first two rows. Or sometimes I'm really just forced to divide. If I've got 2, 3, 5, 4, 1, 2, something like that, here I would really be forced to multiply the top row by 1/2 to get, say, 0, 1, 2, blah, 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 0, 3, 1, blah, 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 0, 5, 2, blah, 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 blah. Okay, so I do this either by swapping or multiplying. And sometimes we might even have to do both. Now the second step here is to get zeros below the 1 that we just placed. So we want to get zeros below this one or zeros below this one, and we do this by adding multiples of this row to the rows below. So if I had, let's just say I started with 1, 2, 3, blah, 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 I would want to take the first row and subtract twice the first row from the second row and subtract 3 times the, so I would do here -2 times the first row plus the second row would replace the second row, and -3 times the first row plus the third row would replace the third row. It's always going to be take whatever number you need to, the negative of this number or this number to make that cancel out, and that gives you 1, 0, 0, dun, 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 da, 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 da. Okay. What do you do after that? Well, step 3 is we repeat this on the submatrix. I'll explain what that is in a second. Ignoring the row used in step 2. So what this means is, let's suppose I've done step 2. and I end up with something that looks like this. Well, I've already got a 1 up here and zeros down here, so what I'm going to do is I'm going to pretend like this row here does not exist. I'm just going to say, okay, you're not there. I mean, he is there, but we're just going to ignore him for a second. Now looking at this matrix right here, I, repeat step 1. Explicitly, I meant to say I repeat step 1. So let me say up here that I really mean to repeat step 1. So what this means is to get a 1 in the at the top of the first column that has not all zeros. This column has all zeros, so right here we want to get a 1 there. And again, we either do that by swapping 1, 2, 3, dot, 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 0, 1, 3, dot, 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 0, 2, 1, dot, 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 dot. So I could have either swapped these two guys to get this, or I could have divided, say, this guy by 2, 1, 2, 3, dot, 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 0, 1, 1 half, dot, 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 0, 1, 3, dot, 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 dot. It doesn't really matter which way you do it, you'll always get the same result. So in any case, I'm trying to get a, again, just showing that we are ignoring this first row here. Ignoring the first row, all we're trying to do is make this, repeat step 1 with what we have below, which is namely to get a 1 up here. And then step 4 is to repeat step 2, but now we using the entire matrix. I don't know why I put an exclamation point there. I just did. We repeat step 2 using the entire matrix. And so this time we want zeros, that's not a 0, zeros above and below the 1 in the row. That we just worked on. So for example, let's work with this one right here. What I would have to do then is I'd want to get rid of the 2 up here. So I would take -2 times the second row and add it up here, which would give me 1, 0, -3, dot, 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 dot. The second row I would leave alone, dot, 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 dot. And the row below it, I would take, again, -2 times the second row and add it here. And I would get -2 plus 2 is 0. -6 plus 1 is -5. Dot, 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 dot. And then I would keep going. With the next step being, let's ignore both of these rows up here and go down here. Turn that off. And so when do you stop? You stop when one of two things happens. A, you get a reduced matrix, or B, you get a row that looks like this. So here's my matrix, and remember it's an augmented matrix, and I've got a bunch of rows up here, da, 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 da. And let's suppose I end up with one row that's all zeros, and then has like a 3 here. Well, this here corresponds to the equation 0 is equal to 3, and that tells us that we have something inconsistent. So what does this mean? With A, we actually get solutions whereas with B, we will get no solutions. Because B means that we get to a contradiction, whereas A means that we actually get to something that we're able to solve. And we've seen an example where we're able to solve it. We'll do a couple of more examples where we are able to do that. And we'll see a couple of examples where there are just no solutions.